All right, so we're going to learn about a constant first. You know, like pi is a constant when you're dealing with circles. So there's a little e, and I'll show you where that is on your calculator. But this little e is what we call Euler's number. Euler's number. And they use this in investment problems when you got continuous compounding. And we're just going to learn about the value of it and how to evaluate it. Now, if you get into a class like business calculus, they'll play with that a lot more, okay? So I'm going to use, when you see these squiggly equals, that means we're approximating this, okay? So I'm going to show you on the calculator how to approximate that. So I'm going to share my calculator. So right over here above the division sign, above the divide, there's a little blue E. So if you hit the second button and then the divide button, that pulls that little E on the screen. Now what I'm going to do is estimate it about 4 decimal places by hitting enter. So y'all, if I was going to estimate that, that would be 2 point. So 4 decimal places is to the right of the decimal. So that's definitely a 718. Now the 4th digit will be to where the 2 is. That means I got to look at the 5th digit to see if I'm going to keep it the same or round up. So since the 8 following the 2 is bigger than 5, I'm going to round that 2 up to a 3. So that would round off to 2.7183. Okay. So what I'm going to do now is show you the 2 problems that MathLab is going to do with the E so that you know how to punch them in. So what I'm going to share is MathLab real quick. So look here for number 1. They want us to figure out e to the 7th to 4 decimal places. All right, y'all, so we'll go to the calculator. So that was e to the 7th. Now, I'm going to show you 2 ways to do this. The first way, you can hit second, divide, get the e, and then use the caret, the upside down v, and put in your exponent of a 7. So that's one way you can evaluate it. Now, another way, I'm going to clear that. You see over here by the left side of the 4, you've got an LN button. Well, if you look above the LN, there's a e to the x. So let me clear this whole thing up here. So if I hit second LN, it brings the e up with the exponent already, and I can just put in my 7 that way. So either way to get that e to the 7th. All right, so we're going 4 decimal places. So that'll be 1096 point. So we're going 4 decimal places. So that looks like what, a 633. So the 1's in the 4th spot. So I got a 5 behind it. So remember, if it's 5 or greater, you're going to round up. So we would make that a 0.6332. Okay. So in MathLab, we would put that whole thing in on that. What I get? 1096.6332. Okay, so 4 decimal places is what you need on that. All right, now number 2 has e to the negative 3.43. So we're going to approximate that out 4 decimal places. So y'all, let me go back to my calculator. So I'm going to use the second LN to get the e with the exponent. I'm going to put in a negative 3.43. Hit enter. And this one's going to give me what, a 0.0 0, 3, 2, and then let's see, the next 3 has an 8 behind it, so I'm going to round that 3 up to a 4. So that'll be 0.0324. All right, so then you would put that in 0.0324, and then check and be done. All right, so before I look at the next ones, I'm going to go back to my pad. All right, so that's just learning about a new constant we call Euler's number, okay? So now let's get into graphing exponential functions. Now, these are graphs that look like y equals a to the x. So the a we call the base. And now notice the variable is up where the exponent is now. Okay, so our first experience with the exponent being my variable. Okay. Now I'm going to show you two patterns these make after we do one example, okay? And then I'll tell you some properties about these. So I'm just going to show you what a graph of f of x equals 2 to the x. All right, just to get a feel about these exponential graphs. All right, so there's my x and y. I'm going to set up a table. I'm going to pick some x values to throw in here. Evaluate them to get my y value or my f of x. Remember, y and f of x are basically the same thing, okay? So 0. I'm going to put a 0 in for my exponent first. So what does 2 to the 0 power equal? Actually, anything to the 0 power will equal this. Do y'all remember that?
One.
1. Good job. So no matter what the base is, if the exponent's a 0, the y value is going to be 1, which means every single exponential function, unless I'm doing translations to it that we'll do later, but no matter what this number is, if that's a 0 there, the y value will always be 1. So let's go over here. Let me just make a few marks here. So that means 0, 1. Every one of my exponential functions will pass through that point on the y-axis. Now I'm going to put a 1 in there. So 2 to the first power is 2. So when my x is 1, my y is 2. Now you'll start seeing it grow a little quicker. What if I put 2 for my x? I put a 2 in for the exponent. I got 2 squared. Well, y'all, 2 times 2 is 4. So when I'm at 2 on the x's, I'm up here at 4 now on my y values. So this is starting to get a little curve to it. So let me do one more exponent, because these exponential graphs grow quick. These are the graphs that you've seen with the COVID, and they made them steep curves. Because think about that, 2 to the third power. 2 times 2 times 2 is giving me 8. So when my x is 3, see, I need more lines up here. When x is 3, my graph is up here at 8. So you see how it's making that curve now. Now this side is going to make like a horizontal asymptote. It tries to get down to the x-axis, but it can never get there, okay? And then this right side is just going to keep growing up and up and up. Okay. So these are your exponential graphs. So properties of my exponential graphs, they all go through to 0.01. Right? Because we said anything to the 0 power equals 1. They're continuous. So continuous means it don't have anything that's going to make it undefined. It's just a nice, smooth, continuous graph. Okay. And then the third thing, like I said, it makes a horizontal asymptote with the x-axis. Okay. So there's two things that these graphs look like. If we got y equals a to the x, pretty much what I graphed, then we know what that's going to look like. If it's y equals a to the x, it's going to be that nice smooth curve we just did. It's going to come and go up. But y'all, there's another case. What if I got a fraction raised to an exponent? Now, this a over b has to be less than 1. Okay? So it's got to look like a proper fraction. 3/5, 2/7. Okay, it's got to be less than 1. If that's the case, then this graph, instead of going uphill, sort of goes downhill. It still crosses at 0, 1, but it makes the horizontal asymptote to the right side instead of the left side. So my proper fractions will go downhill left to right. My whole numbers or my integers will go uphill left to right. Okay, so what I'm going to do is show you how to graph these on your calculator. Now, knowing these pictures here, you can pretty much guess these graphs, okay? So let's go to Math Lab and start with this number 3 here. They got y equals 4 to the x. Knowing what we just drew, would y'all pick A, B, C, or D? Because remember, that 4 would be like my A now. All right, so my chat is lighting up. So I'm getting C. Let me see. C, yeah, remember C is the one that goes uphill left to right, because that 4 is not a fraction. Now, y'all, these ain't bad to graph on your calculator. Get that calculator, go to y equals. And we had what? 4 to the x. So that'll be 4 exponent x. So now if we graph that, there you go. It's the one y'all picked. Goes uphill left to right, crossing over at that 1 on the y-axis. So yeah, these ones, you'll just pick one, check your answer. All right, am I locked up? Let's see. Let me go to. Oh, it's 4 giving me the same problem, I guess. Well, A, B, C, or D? It looks like it gave me the 4 over x again. What y'all picking?
Is it A?
It's A. So A on that. Good job, chat. All righty. So maybe it'll give us a different one. See, that's the thing. When you got the same kind of questions, Math Lab is not always got different problems in there, you know. Now, this is.
B.
So which one?
B.
B there. Remember, it goes downhill left to right, and it will not cross over that x-axis. So go with B to where D, it sort of went below the x-axis, okay? Now, let me show you how I would graph the fraction on my calculator. The thing with the fractions, when you graph them, you got to put them fractions in parentheses when you got an exponent, okay? So you want to put your parentheses, and then you can hit the alpha y equals and enter to get the fraction up. So we had a, oh Lord, what was it? Let me go back to my problem. I had a 1/3, okay. So we had a 1 on top, 3 on the bottom, and then arrow out, close the parentheses, and then put in your variable for the exponent of x. But y'all, you whether you use that fraction button or if you do like 1 divided by 3, the 1 divided by 3 has to be in parentheses, okay? That way the exponent affects the top and the bottom. All right, y'all, then when we graph it, there's that picture y'all picked. See how it does not cross over the x-axis. So that, and y'all said was B, I think. Now this one's a little tricky. You see a fraction, but guess what? The fraction ain't what has the exponent. The exponent is on that E. So we know it's going to be A or B. So let's get a picture of this and see what we get. So I'm going to go to calculator. This is what? 2/7 E to the X. So that time, since I did the fraction with the alpha y equals, on this one, I would do parentheses 2 divided by 7. Then I would get my e to the x by hitting second ln and then putting in my x for my variable. Now I will say, since the exponent don't affect the fraction, when you do it the other way, you can do the 2/7 without parentheses because the exponent only affects that e, okay? Now, we know we got to watch this one close to see where it's crossing that y-axis. So I'm going to hit graph. So notice, looks like it's crossing right about 0, 1 on that. So we want to pick what picture looks like that. So y'all, looks like I'm going with A on that one, right? It sort of crosses at 1 and then goes up. This one starts going up on the left side in the negative side. All right, I think 7, I'm going to start showing you transformations. Okay. All righty, so back in 7.2, we learned about transformations. So we could move our graphs up and down, left or right, and then we could actually reflect it over the x-axis. So now we're going to look at transformations for the exponential graphs. So transformations for exponential graphs. And remember, those will be the y equals a to the x, okay? So I can still do vertical. Vertical would be up and down, and to get a vertical, I would have y equals a to the x plus or minus b. So the same way before, we took our function, the x squared, added or subtracted a number from it. If the b is positive, well, back in 7-2, if y'all's b was positive at the end, that moved it up. And if our b was negative, then it's going to go down. So that vertical move is the same as it was in 7-2. Now we can move these horizontal. So horizontal will be left or right. So to move a graph left or right, I'll have y equals a to the x plus or minus c. Just like in 7-2, I'm attacking the variable. Remember, in 7-2, it was inside the parentheses. We had like x plus 2 squared, x minus 5 cubed and stuff. I'm still attacking the x. So if I add or subtract from the variable, if the c is positive, and y'all, this is just like in 7-2, it's backwards. When I add to the x, it's going to move me left. And if c is negative, meaning I'm subtracting from the variable, then that's going to move me to the right. Okay? Same thing if I attack the x in 7-2. You added, you went left. You subtract, you're going right. All right, now the last two. This is the new one. Reflection over the y-axis. So to make these graphs reflect over the y-axis, you'll have y equals a to the negative x. If we make the variable negative, it's going to reflect over the y-axis. And y'all, the last one is one we've already done, reflection over the x-axis. So reflection over x-axis is just like we did back in 7-2. You'll have y equals negative a to the x. So y'all notice the difference. Negative exponent, it's the y-axis. Negative in front of your base, it reflects over the x-axis. All right, so I would keep this handy for the next 5 or 6 problems or so, because I'm going to be going right off of this and showing you how to graph them. Now, it's important that you realize on these, we're going to get a little box that opens, but on these ones, we have to tell MATLAB what base we're starting with. And I'll show you one of those as what I mean when we're doing this problem, okay? So let's go to MATLAB. So y'all look at this problem. F of x equals 2 to the x minus 3. Then you gave me A, B, C, and D. Now it says start with the graph of y equals blank to the x. That's where you put your base, which is the 2. But what I got to know is I'm subtracting 3 from the variable. Is that going to move me up, down, right, or left? So light my chat up. Up, down, right, or left? Okay, so let me see. Okay, I'm going to go right because we're subtracting the 3 from the x. So I need to choose the one that says 3 units to the right, which would be C. And then remember, I'm starting with the graph of y equals 2 to the x. Okay, so all we do is put our base there, and then it's got the moves I'm doing, shifting it to the right. So we would check that answer, and then it's going to make us graph it. So I'm going to click to enlarge graph. Remember, exponential tool is on the second row, second tool. It says exponential. You're going to click that and then click anywhere on the graph. It will start it in the middle. Now, the only move we did was horizontal to the right. So I'm going to go down here on the horizontal, move that right 3. And that's moving my graph for me. Now, do you see in the bottom left down there, it says base? By default, it's got that little E for Euler's number down there. By default, you got to change that to match your problem. So since my base was 2 in my problem, I have to change it right here and then save it. After you change your base and do your moves, check your answer, and we'll go to the next. Oh, now this one wants me to graph it first. But here's the thing. I need to know what that -4 is doing to my graph before I can graph it. So that -4 at the end of my function, up, down, left, or right. All right, because see, we know what tool we're using. So I'm getting down, and that sounds good to me. So I'm going to use my exponential tool, click on my graph, and vertical went down 4. So go to vertical and go to -4. It moved my graph down. Notice in the bottom left, base. I got an E there. I've got to change from the E to my 2. So the base will always be the number in front of that exponent, okay? So y'all, we will save that one. Check the answer. Now don't worry, I got some good tricky ones coming up. Oh, so we didn't finish yet. So we're starting with y equals, what do we got? 2 to the x. But y'all be careful because this one has 2 times x. We need 2 to the x. Looks like an exponent, okay? And then I guess we shifted down those 4 units. So some of them you got to know to move before you graph it. Some of them you put the moves after you graph it, okay? All right, y'all, so let me write this one down because I'm going to show you some tricks I do to this one. So that's 2 to the 2 minus x plus 3. There's a few of these I rewrite to get them in the right order. So on this one, I like the variable being before the number on the exponent. So I'm going to make that a 2 to the negative x plus 2. And then I still got my plus 3. Okay, I don't know. I always just like to put them in order because then you can see that the exponent, the variable is negative, and they're adding 2. So negative exponent's going to reflect it over the y-axis. Because of that negative exponent. That 2 is being added. So we said if you add to the variable, it's going to go left. So this thing should go left 2 units. And then at the end, we got a positive 3. Or that 3 at the end, that should move us up 3 units. So that's the moves we got coming out of this problem, okay? Now, you don't have to rearrange it, but realize that that negative applies to the x, and that will make that negative, okay? All right, so let's look at Math Lab. I can't remember if we had the well, it looks like we're graphing it first, right? So here we go. Click our exponential tool. All righty, so let's see. I got my base of 2 down here. We went left 2 because of that positive 2. Oh, where'd it go? So negative 2 reflected over the y-axis, we said, and then vertical went up 3. So it's going to make us do them order. Now it'll make us actually say that. So we started with 2 to the x, and we just did our moves, right? We went left 2 units. We reflected over the y-axis and went up 3. So y'all let me see. Oh, no, A's got the x-axis. Let's see. B, left 2, reflect the y, shift up 3. So that's the one we want. So what was the... Oh, and then C had down 3. So they moved down instead of up. So we want B on that one. And then next question. I think this is another one that I would rewrite. All right, so let me write this one down. F of x equals 4 minus 3 to the negative x. All right, so I'm going to show you how I would write that one so it's not as confusing. Instead of this 4 being at the front, I would move it to the back so that I got my negative 3 to the negative x plus my 4. So just move the 4 to the back so it don't mess you up on your... Because my base is a 3, actually, okay? So y'all look at all the moves I got. The negative x, that negative x is going to reflect me over the y-axis. This negative in front of the 3 is going to reflect us over the x-axis. And this plus 4. Well, y'all, what's the plus 4 doing? All right, so waiting on the chat on that. All right, so remember that
Is it
4 is
going
at the
left?
end. It's not attached to the variable, so okay, going up. Good job. Up 4. Good job, y'all. So that will make it go up 4. All right, so reflect the y, reflect the x, and up 4. So let's go find one that says that. All right, let's see. Y-axis, x-axis, and then shift up 4. So it looks like A. B don't even have the x-axis, and then C don't even have the y-axis. So the only one it can be is A. Now notice, although the 3 was negative, I put the base of 3 only. The negative was taken care of with these flip across the x-axis. So don't include the negative on the number, just the number. All right, so you check that, and guess what? We get to graph it. So this one, I just go in order of what they gave me. So let me click on the graph. So we picked A there, remember? So we reflected the y, the x, and then up 4. So I'm going to reflect on the y-axis. Click that box. Reflect the x-axis. Up 4 would be vertical, up 4. And guess what else? The bottom left, that base is an E again. I need to change that to a 3. So remember, do not include the negative on the base. So you'll save that and check your answer. All right, y'all. So I think this is the last one that deals with this graphing. So what I would like to know, let me make sure. Yeah, this is the last one, and then I'll show you a formula. So what are y'all going to start with the graph of y equals what to the x? So what is my base?
2x.
So it's going to be a 2, so we're going to put a 2 in there. Now it says shift it 4 units, blank 4 units. Well, the 4 is being added to the variable. So is that going to go left, up, down, or right? All right, so chat's lighting up now.
Is it? Wait a minute. If it's negative, won't it be down?
Well, I'm looking at the 4, not the 5.
Oh, oops.
Y'all
So,
look at that 4 up there. Chat, y'all are wrong. Y'all got to look at the. Remember, the 4 is being added to the variable.
so you go up, right? Left.
Uh-oh, let me get y'all back here. Let me go back to my pad. I'm going to have to. Oh, let me check one in real. Okay, got it. All righty, y'all, look at this. This is at the end, but it's not messing with the exponent. If you add a number or subtract it at the end, up and down. But look here, I'm attacking the exponent with this one. X plus C or X minus C. If C is positive, left. If that C is negative, right.
Oh, okay.
Pay attention to that one because I forgot. I got an X plus 4. So what is that doing? Shift it blank 4 units.
You're gonna do left.
He left.
All right, it's going to be left. Now at the end is the minus 5 being subtracted. So now is that one going to be right, up, left, or down?
That's gonna be down right there.
That's going to be down. There you go. So if the first one took care of the left or right, then the last one's got to do the up or down, okay? All right, y'all, we would check that. So y'all did all right on that. So let's graph it. We're going to click, grab our exponential tool, click on the graph. Y'all went left 4, I think y'all said. Oh, where'd my stuff go? All right, there it is. So left would be horizontal -4. Down 5, I think we said. So that would be vertical down 5. But remember in the bottom left, there's that E again. So I got to change the little E into a base of 2. Okay, y'all, so then save that. Check our answer. Now I'm going to try something.
Say it was horizontal -4 or just or +4.
Oh, since that was X plus 4, that actually went left 4.
I mean, when we graph it, would it be?
Well,
It
when
would
you
be
graph it,
horizontal.
you just do the -4
Okay.
since it went left, and then if it went right, I'd have did +4. Yeah, MATLAB's a little backwards on that, but just because you see a +4 on the problem, you're opposite in MATLAB graphing it. Okay, because you physically got to go left that -4. So y'all
Okay.
try this one. What's going in the first blank? Y equals blank to the X.
2.
All right. You're going to shift it blank 4 units. So that has a +4 added to my X.
Left.
All right, so I'm going to go left. Good job, everybody. And then you're going to shift it blank 3 units.
Down.
All right, good job. Down, everybody. Okay, so y'all are getting the picture now, so we'll check that. Now, watch this, y'all. Let me bring that down where I can see. So I'm gonna pick the exponential tool and click. Now remember, although that's a +4, we moved left on our graph. So since my graph, where did my box go? Let me start it over. So since I went left on my graph, I've got to do my horizontal to -4 for my left. Okay. Now the vertical, we went down 3, I think it was. So vertical down 3. So the vertical, the down is negative, up is positive. On the horizontal, left is negative, right is positive. And then change that base to a 2 again. The biggest problem most people usually have on these, y'all, is they forget to change that base over, okay? All right, so that's graphed and we're good. All right, so I'm going to show you all a formula before I do the next two problems. Let me get some amounts first here. So I'm just going to write these amounts down and then I'll show you investment problem. So 83,000 invested at 5.5% interest, compounded quarterly. And then they want me to find the function and all that stuff. Okay, so here we go. All right, so this formula I'm about to show you is a formula that you can use to find the amount of money in an account after T years for an investment, okay? So A of T, so T is the variable for time, okay? Because investments depend on how many years that money's in that bank. Now, A of T is the amount in the account after T years. This A of T equals P times parentheses 1 plus R divided by N, all raised to the N times T. So what do y'all think the P stands for? P is your principal or your starting amount. So like in this problem, 83,000 would be my starting amount. So that would be my P because that's the amount of money that I'm investing, okay? Now the 1 is a 1. So the R, well, what does your investment depend upon? What could that R be? What determines really how much money you make other than the years?
The return.
Well, I'm looking for a different one though.
An interest.
Interest rate. There you go. It's the interest rate. Good job, y'all. Because a higher interest rate, more money. Lower interest rate, lower money. Now, here's the thing. Interest rate in this formula has to be in decimal form. Okay? So they're going to give me like this 5.5%. I'm going to turn that into decimal and not percent, okay? Now, the N here, N is what we call the number of compounds per year. Now they'll use words like, well, up here, quarterly. quarterly compounding would be 4 times a year. So it's the number of times they apply that interest, okay? They'll use like quarterly, semi-annually. Semi-annually would be what, twice? They might do monthly. There's what, 12 months. They could do daily, which would be 365, I think. Or they could use yearly, which would be once. So look for keywords on the N or the compounding. And then guess what? T is our time in years. Okay? And then that N is the same as you'll put here. See, what happens is you take the interest rate and you divide it by how many times it's getting compounded a year. So if it's quarterly, you take your interest, divide by 4. That's how much is actually getting hit every time it gets compounded. And then if you look at it over time, the number of compounds times T, that sort of brings it back up to the yearly total. And then you multiply by how many years you got. Business calculus and classes like that. If you're a business major, you might play with this a little bit in that class, okay? So y'all, let's so part 1 on this, they wanted us to find a function for the amount to which the investment grows after T years. So for your part A on this one, oh, I guess this is A. So this is part A. They just want me to find a function. So they're wanting me to fill into this formula and simplify it down a little bit, okay? So they'll give you the A of T. So we need to start plugging in for stuff. So P, my starting amount, since I'm investing 83,000, 83,000 will be my starting amount. Then we got our parentheses, 1 plus. So we got to figure out R. R is 5.5%. I'm going to change it into decimal and make that 5.5%. So change your halves to 0.5s, okay? Now, how can I change this percent into a decimal? There's a little trick we taught y'all. If you're going from percent to decimal, you move the decimal left 2 units. So you move the decimal left 2 units. That's going to give me a point. I got to fill in a 0 here for that spot. A 0.055. So if you got 4.5%, you'll be 0.045. Okay. So turn it into a decimal and then move the decimal left 2 spots. So that's going to go over here on top, 0.055 divided by N, which is my number of compounds. So y'all, they said it was compounded quarterly. So what are we putting for N? So how many quarters are in a year? So good job. That'll be 4, y'all. So that'll be 4, which means NT will be 4 times T. We got the right formula, but the only thing we got to do now for Math Lab is write this in simplified form. So I'm going to go to my calculator and see what 1 plus 0.055 divided by 4 equals. So y'all, let me do that on my calculator. So let me clear that off. So I had 1 plus 0.055 divided by 4. So we got to simplify this part for Math Lab. So that's going to give me a 1.01375. So what we'll do, we'll replace 1 plus 0.055 over 4 with 1.01375, close parentheses, and put our 4t. Now remember, MathLab will give you the A of t. You got to put this in. Although this was right, it ain't simplified enough for MathLab, and they want it in decimal form, okay? Now, B, I'm going to show you how you're going to love your calculator for this. Because B, they want to know how much is in the account after t equals 0, 4, 5, and 10. Now, let me ask you this. If t is 0, think about this. If t is 0, 4 times 0 is 0. Anything to the 0 power equals 1. So when t is 0, it's got to equal 83,000 because that's your starting amount. And if no time has passed, I better have 83,000. Now, y'all watch this. This one's not bad. I'm going to show you this one on the calculator because we can get all 4 of those amounts quick. Now, I ain't going to lie. If you want to, you can punch them in one at a time. Put a 0 for the t first. Get that answer. Then put a 4 in there for the t. Get that answer, and so on. But we got graphing calculators, so let me clear this one out. I'm going to put in my function, 83,000. Then I had a parentheses, 1.01375, close parentheses, and then my exponent is 4 times x. Remember, in the calculator, you got to make the variable at x. Now, I don't even care about graphing it. I want to see the table. So I'm going to hit second graph. Now, these wanted me to round to the nearest dollar. So y'all, my first t0 would be x of 0. So I'm going to scroll up. And there's x equals 0. Look how much I got. 83,000. So I would put 83,000 in for the 0. Then next it had t equals 4. Well, if I go over here and scroll down to 4, the amount in my account is 103,269. Now, do you see when I'm clicking on these y values above, down here in the little bar, it's giving you the decimal approximation of it. Okay. All right, next was go over here to 5 on my x's. Arrow right. I'm now at 109,000 and 068. So that one rounded up. All right, so I got 4 of them. Now I need to go get t was 10. So let me arrow down to 10. And at 10, if I highlight the y value, I'm at 143,322. See, it's rounding these off to the nearest dollar in the y values up here, but it gives you the decimal approximations in the bar down below, okay? All right, y'all, so we got the 4 amounts. So let's go plug this in. So my formula, remember, was 83,000 parentheses, 1.01375, close parentheses, and then we do our exponent for t. So in MATLAB, when you put in the formula, you got to use the t for the variable. You'll check that answer. And then it's going to make us put in those four amounts we got. So remember, 0 years, it still equals your starting amount, 83,000. 3 years, oh hell, I did 4 years, not 3, didn't I? So looks like I need to go figure out what 3 years is on my calculator. And 6, okay. Okay, so I had 4 and 5, must have been another problem. So I need to go to the calculator and look at 3 and 6. So here we go. So for 3, I'm going to arrow up. So at 3, I got 97,780. Now let me go down to 6. And at 6, I got 115,191. Oh, okay. So let me go put them in. I guess it changes to different years on different people. So 97,780 was that one. 6 years, we said 115,191. Now, the thing you got to realize, the money is growing every few years, right? So if it's a good investment, that money better be going uphill. All right, in 10 years, I had 143,322. So 10 years, their money almost doubled. Okay, they made quite a bit on that. All right, now let's see the last question. Let me write this one down. So on Melissa's 6th birthday, she gets a $5,000 CD. It earns 4% interest, compounded quarterly. If it matures on her 10th birthday, how much money will be available? All right, so let's go work that one out. We'll get our formula and everything, and then since there's only one amount we're looking for, I'll probably just punch that in on the front of my calculator. So y'all, were you still using our same formula? P times 1 plus R divided by N to the NT. So I'm going to let y'all fill me in. What is my principal? What are y'all putting for the P?
$5,000.
5,000, good job. And then we got 1 plus, R is 4%. But what are y'all putting in my formula here for R?
$4.
Well, remember, you got to turn it into a decimal form and not percent.
Oh.
So move that decimal left twice. So it's behind the 4 when you don't see one. So you're going to move it twice to the left. So that means we're going to add a 0. And 4% would be 0.04. All right, that's going on top. What am I putting for N?
4.
4, because quarterly. And then 4 times T. Well, what in the world is my T? She got it on her 6th birthday. It matured on her 10th birthday. So how many years would y'all say passed? So 4, that sounds good.
4.
Mm-hmm. So now I'm just going to punch this on my calculator and see what we get. Now this one also said round to the nearest cent. So the nearest cents, that means we got to have 2 decimal places. Okay, so let's go punch that in on our calculator. So I'm going to get off my graphing. And y'all, like I said, I'm just going to punch it on front here. So I had 5,000 parentheses 1 plus 0.04 divided by 4, close parentheses, and then my exponent was 4 times 4. Or I guess you could have put 16 there if you multiplied it already. All right, remember, we started with 5,000, so it better be more than 5,000, okay? And let's see what we got. All right, let's see, 5,862. All right, 2 decimal places. So that 9's in the second spot, but it's got a 3 after it. So that's going to be 5862.89. So we would punch that in. So I mean, the little girl made about $800 and something, I guess. 5862.89. So yeah, almost 500. She almost made $863 actually. So y'all, then you would check that and be done. So y'all, that is your 9.3, okay? Learning about E, Euler's number. Looking at graphs and transformations, and then working your investment problem, okay? No support for this section. It was just 9.3 college algebra only. And then let's see, Thursday night we will do 9.4 college algebra. And we're going to be dealing with logarithms, so definitely bring a calculator to class that night, okay? All right, I'm going to stop my screen recording.